Okay, here we go. Now, determine whether the triangles are similar. If so, write the similarity statement. All right. Now, yesterday we were given that the problems were similar already, and now we're trying to prove that they are similar. Yes, sir.
It's 1 through 14, 16 to 24, and 27.
All right. And so yesterday, like I said, we were given that they were similar, and then you had to tell me the corresponding parts. Now your job is to determine whether or not the triangles are similar. All right, there are just two rules for similarity between triangles. All right, and the first rule is if two angles of a triangle are congruent to two angles of another triangle, then the triangle is automatically similar. All right, now remember we said if the angles, if you have similar figures, then the angles are always what? The angles are always congruent, and the sides are always what? The sides are always proportional. Thank you. All right, so again, sides are proportional, angles are congruent. It's just too much, angles. You know what I'm saying? I don't, it's just. Now, today, there are a few ways in which you can determine whether or not triangles are similar, and it's completely different from any other polygon, because you can have polygons with equal angles and not be similar. For example, we talked about a square and a rectangle. The angles are all the same, but the shapes are not similar. All right, well, triangle is unique. All right, if the angles are congruent, then the triangles are automatically what?
Similar.
They're automatically similar. So this is the only polynomial, or it's the only polygon that is true for. So for question number 1, we're trying to determine if those triangles are similar. And the answer, of course, is what? Yes, because we can prove what?
The sides are proportional.
We can prove what? We can prove the angles are what? The angles are congruent. We don't know anything about the sides. Now, if you recall, the third angle theorem means if two angles of one triangle are congruent to two angles of another side or another triangle, then the third angle is congruent. All right, so that's why it's kind of, they call it angle-angle similarity. But in reality, if two angles, then all three angles are congruent. So what your job right now is to do is to look at question number 1 and say, well, what angles can we prove are congruent? And right off the bat, go. VZW and XZY. That is correct. Those are congruent. Now, what else? Thank you.
Angle
Yes, that's the one that's important. Those two angles are congruent. And again, perfect. They are alternate interior angles. Just like you could have said angle X is congruent to angle W, but we don't have to prove what? We don't have to prove 3, we just have to prove what?
Yeah.
We just have to prove 2. So we would say, question number 1, all right, the triangles are similar by angle-angle similarity. Now that's what's coming next. All right, what's coming next is you have to write the similarity statement. All right, so when you write the similarity statement, that just means you have to say, for example, the left triangle, I would call that triangle XYZ is similar to, now you have to say that X corresponds to what? W, and Y corresponds to, or I'm sorry, Y corresponds to V, and Z corresponds to what? Z. All right. So triangle W or XYZ is similar to triangle WVZ. All right, again, I just think that's very basic, very simple. All right, so one rule is angle-angle similarity. As soon as you prove two angles of a triangle are congruent to two of the other angles, then the triangles are automatically similar. All right, so now let's take a look at question number 2. All right, now in question number 2, all right, we have the fact that there's these angles, correct? Do we know anything about the other angles? No, so we can't use angle-angle similarity. All right? So in this case, however, if we do Pythagorean theorem, we can figure out what BC is. And that would be 5. All right? You're supposed to know the triples. All right? One of the triples is 3, 4, 5. All right? If you didn't know that, you would just do 3 squared plus 4 squared equals C squared. 9 plus 16 is 25. Square root of 25 is 5. Anybody have any questions with that? So now we know that BC has to be what? 5. All right? Then, does everybody see if I did the Pythagorean theorem for E or DEF, everybody should be able to say that FE is what? 8. All right, and the reason we know it's 8 is because they're triples. So if you multiply 3, 4, 5 by 2, you get what? 6, 8, 10. So if one side is 6 and the hypotenuse is 10, the other side has to be 8. All right, now can you tell me if those triangles are similar? Yes, and they are similar by side, side, side similarity. Side, side, side similarity. So if two angles are congruent, they're automatically similar. All right. The other one is, notice I didn't write side, side similarity. All 3 sides have to be proportional. All right. In order for it to be similar. All right. So in this case, we could say side, side, side. The other way to prove, the only other way is to prove through side, angle, side similarity. All right. Now, is it true that this could be side, angle, side? Yes. And what side, angle, side is showing you is that the included angle, which in this case we can call the 90-degree angle, all right, and then we look at the two sides. This side right here is 3, and this is 6, this is 4, and this is 8. So are the two sides proportional? Yep. And the angle is congruent. Therefore, you could say it's side, angle, side similarity. All right? Anybody have any questions? All right, so let's check out question number 3 now. Are those similar? Oh, we didn't write the similarity statement. Sorry. So let's write the similarity statement. For the left side, I always just like to try to go in alphabetical order. So we'd say triangle ABC is similar. Now, A is the what? Right angle, correct? So that would be what? F. All right. Now we're going from A to B, which is technically the short side. So we would say A to B would be the same as from F to D, and then E. I'm listening carefully. Tell me.
Does it matter what order the points are?
No, you could say BAC, you could say CBA. It doesn't matter. That's why sometimes it's kind of hard, a little longer for me to grade your test, because I have to check all of the angles that correspond. All right. Does everybody agree that's really not hard? All right, so let's take a look now at question number 3. All right. Now, in my opinion, what I like to do when I have all three sides is write small to large. So what I mean by that is 6, 8, 12. And then on the other side, it would be what? 4, 5, 8. Right? Again, you don't have to worry about it if you write them in numerical order. All right? So obviously, are these similar? No, they are not. All right? Not similar. All right? Walker, did you have something to add?
Oh yeah, I was just saying they're not similar because my reasoning, if you ask for like the reason, I just put none of the tests.
That's right. Thank you. The sides are not proportional. All right? Now, for question number 4, again, I think it's just important to write small to large, 10, 15, 20, and then small to large over here would be 4, 6, and what? 8. Now the question is, do they reduce to the same number? 5 over 2, 5 over 2, 5 over 2. All right? So we'd say this is yes by side, side, side similarity. And so now JKL, triangle JKL are similar to triangle. Now again, from J to K is the large side to the middle side to the small side. So yes, large, medium, small. S, Q, R. Now look, it is considered wrong if you do SRQ. Does everybody agree with that? All right, so that's why it's important to understand how to label them and how to see what letter corresponds to the other letter. Very important. All right, anybody have any questions with that so far? All right, let's see about number 5. In the figure, AB intersects DE at point C. Which additional information would be enough to prove that the triangles are similar? So what do we know already?
Angle ACD is equal to BC.
Perfect. All right. Now, the next thing I like to see is, since I'm given one angle, the easiest way is to find what? Another angle, all right? Because we at least need what? 2 sides. Do you agree with that? All right, so let's see what it says. If I show that angle DAC is congruent to angle EC, does that make sense? No, that definitely doesn't make sense. Now, what about if I say, that AC and BC are congruent? Because that's only going to give me what? One side, right?
C.
Ooh, let's look at C. If AD is parallel to EB, would that do it?
Yes.
Yeah, because then you could say alternate interior angles are congruent. So I'm liking that C is correct. Now it's important that you understand what we just said now. What? Why couldn't it be what? Say B.
BC equals CE.
Where does it say DC is equal to?
AB
Oh.
intersects DE.
Yeah, it says AB intersects
No,
D.
not bisects.
Yeah, not bisects. Agree with that now? All right, now this is what I want to hear, guys. All right, speak up when you don't see something. I'm trying to tell you, to me, geometry is visual. That's what's hard about it. If you can't see it, it's not your fault. Right? We just got to draw it out, and I got to show you better. All right? And if you're not seeing something, put your hand up. Besides
I
Walker.
see how you got C, of course, but wouldn't D also work because the CBE was the right angle?
Okay, hold up. Let me write that. Hold up. I don't care if it, all right? I'm going to mark it as a right angle. CBE is a right angle. Okay, so if that's a right angle, which is, I can definitely see that. All right, if that's a right angle, what else does that tell me? Shh.
Wouldn't that tell you and then, never mind, I see what I'm telling you.
So, okay, now, he is correct. If this over here was a right angle, we would be in good shape. All right, you with me? All right, so clearly C is correct. And believe it or not, the parallel is the one that, for whatever reason, throws everybody off. But I tell everybody, as soon as you know the lines are parallel, the alternate interior angles are congruent. So it kind of gives it away a little bit. All right, any questions with that? All right, here we go. It says, identify the similar triangles and find each measure. So now I need to, they're saying that the triangles are similar, correct?
Mm-hmm.
So the triangles are similar by angle-angle similarity. Agreed?
Mm-hmm.
All right, if the triangles are similar by angle-angle similarity, now it's just a matter of you have to line them up properly. All right? So I know that I would say triangle XYZ is similar to what? Triangle
JKL.
JKL. Now, the reason why I like writing the similarity statement is because if you can write the similarity statement, you can't be deceived by the figure. And what am I saying by that? If you look at the figure, it's twisted around. Does everybody see how it's twisted around and flipped over?
Uh-huh.
So it's so easy to make a mistake on what goes with what. Whereas if you have it this way, you can say, for example, XY. XY corresponds with what?
JK.
JK. So XY over JK is equal to, now I have YZ. YZ corresponds to KL, which is what? X. I mean, it's just really that simple. Now, does everybody agree I could also say 5 over 15 is equal to 4 over X? We get the same answer. And in many cases, you can say, well, it's just 3 times larger. Right? Do you agree with that? Right? 5 over 15, 3 times. So X has to be what?
12.
X has to be 12. All right, and I don't care about solving proportions because literally we've been doing that since 5th grade. So I don't think the proportions are hard. I think what gets people messed up is the fact that the triangles have to be set up properly. That's what's hard. Just like for number 7. Walker, do you have another question?
Yeah.
Tell me,
How
bud.
did you, I'm thinking if it's possible to find stuff out of it.
Well, I just did in my head 4 times 15 divided by 5.
16 divided by.
Today is 12, yeah.
Oh. I was doing 1/2.
All right, now look, the other way I can show you this, look right here. I like this way because I can see that the larger side is 3 times the smaller. So 4 times 3 is 12. I didn't have to cross multiply on that. Do you see that? Walker?
Oh, so I was
All right, here we go. That's all right. All right, here we go. Now, on the SATs, I want to show you, this is a question that's on the SAT all the time. All right? However, they will ask you not about that. They will ask you about VT. Now, let me ask you a question real quick about VT. Is VT a side of a triangle? Yes or no?
No.
No. That's what everybody seems to forget. VT has nothing to do with a triangle. It is part of a side of a triangle. It is not a side of a triangle. Now, again, I say that every year, and everybody's like, oh, yeah, that's so obvious. Oh, obvious. And every time I say, this to me is the easiest chapter in the world because you're just solving proportions. And every year it comes back, a couple people don't see what I'm seeing. Does everybody understand what I'm saying? If I'm asking about VT, VT is not part of a side of a triangle. So you can't use VT as part of the proportion. All right? And that's going to come up later on in this section, I believe. All right. So here, everybody should be able to look at that and say, obviously, x is how much? Obviously, it's 20. If you're not saying it's 20, you just need to speak up. What?
I don't.
Okay, so here is what I'm trying to tell you. You can set the sides of the triangles are proportional, or another way to solve it. Look up here, please. I'm looking at this and this. The base is 4 times the side. Correct? So here is the side. So the base has to be what? 20. If you don't like that, you can say 3 over 5 is equal to 12 over x.
Oh.
But I would prefer that you just look at it and say, okay, the small triangle is similar to the what? The large triangle. All right? Any questions? All right. So now let's look at number 8. All right. Now here it says a cell phone tower casts a 100-foot shadow. So here's my tower, and here is my shadow. All right. Now, I don't know what the height of my tower is, correct? But I do know that my shadow is what?
1 feet 4.
100. That's okay. It's 100 feet. All right. Now, I am going to say, too, because I know this sounds really silly. The shadow is always on the what? On the floor, on the ground. Okay? I have kids every year draw the shadow in the wrong spot. I know you're laughing now, all right? And when you look at your test and you put your shadow as the hypotenuse or something, that's a problem. All right? The shadow is always on the ground. Do not put it anywhere else. All right? Nowhere else. Now, again, is it really even necessary to draw the triangle? No, because I'm not interested in the hypotenuse. All right? It says next, at the same time, somebody who's 4'6", but instead of saying 4'6", we're just going to say what?
4.5.
No, we're not going to say short. We're going to say 4.5 inches, right? So here you are, standing over here, all right? You are 4.5,
You're a post?
all right?
Posts?
Yes.
And your shadow, how long is your shadow?
3.3.
What is it?
3.3 repeating.
Yes, we'll call it 3 1/3. What's the matter, Walker?
Why is it 4.5 not 4.6?
Are you sure? 6 inches.
6 inches. 12 inches a foot. Half.
All right. So shall I do 3.4 for the next one?
It'd be 3.3. Yeah.
Wow.
3 1/3. So we're at 3 1/3. All right. So again, here is where we're saying 4.5 over x is equal to
3 1/3 over 100.
3 1/3 over 100. Yes, again, you're looking for side to side, shadow to shadow. All right. Now again, I don't mind you using your calculator.
136.
What is it?
136.
I've got several different answers now.
I got 15.
100 and what?
That's very incorrect.
136.4 feet.
That's what I got.
Now,
I think you're.
Or 135.
I got 135.
It can't be 135 inches.
No, 135 feet, but I did inches.
I did it in 136 feet.
All right. Well, again, it should be exact, okay? I don't want to have separate answers now. So if you're having trouble, remember, 3 1/3 should be typed in as 10/3. All right? That would help you. So then 4.5 times 100 is 450 is equal to 10/3 x. So 3/10, solving that, 45 times 3, 135 is equal to x. Some of you guys who are rounding off, that's causing problems. All right, you're not doing 3.3 or 3.33. So I need to make sure now, if you're using a calculator, you know how to use your calculator properly. All right, so those of you guys who got 136, we've got to figure out the problem. I'm not sure where 136.4 comes from. I got 135 what?
Feet.
135 feet. All right. Anybody have any questions with that?
Number 9.
Okay, let's take a look at 27. I don't think I want to write the proof for you, but we'll talk about it just to make sure. All right, so it says, given triangle XYZ and triangle ABC are right triangles. And then it says that XY over AB is equal to YZ over BC. Wow. So I don't even know why that's really a proof, right? So how do we know those triangles are similar now? Yeah, it's just side angle side similarity. Yeah, that's what I was thinking. I don't. Yeah, so let's just do side angle side similarity. I don't know why they would do that. I guess you would have to say that all right angles are congruent, and then you're just using side angle side similarity. All right. Did I ask you to do 28?
No.
All right, let's take a look at number 11. Okay, here we go. So it says determine whether the triangles are similar. So I'm assuming here that FB is 9, right? And then this triangle right here is, or this side is what? So I have a triangle who, right now I'm thinking it would be side angle side similarity. I'm not saying that's true. I'm just saying that's how I would prove it. Do you agree with me? And how do I know that? Because I have this side right here, right? I have this side right here, and I have this side right here, right? Does everybody agree with that? So then I have from that, in this, I would have 6 and a 9. Does everybody agree with that? And then the angle is the same. Now, the small side is what? On the other would be 10, and the large side would be what? 15. And do you see how that reduces now to what? 3/5 and 3/5. All right. So now we have proven that those triangles are congruent, or not congruent, but they're similar by side angle side similarity. What's the matter? Come on.
Oh, for 10?
Or okay, hold on. Let me finish this one up. All right. When you said 10, I was thinking that. Okay. So again, now they want you to write the similarity statement. So I would say ABC, triangle ABC is similar. Now, AB is the long side, right? So FB is the long side, but is it F to B or B to F? I think it's FB. So FB what?
D.
D.
I don't get it.
What's the matter, Walker?
Well, I'm trying to get the 9 over 10 and I mean 6 over 10 and the 9 over
Because I looked at the angles that I created, the pink angles. Do you see the pink angle? So that length here, try to watch me now, Walker. This right here, you see what I'm highlighting now?
Yeah.
Is the big triangle. The one side, the small side is 10, and the large side is 15. Do you understand that?
And you got the large side.
No, I got the large side because 6 plus 9 is what? Come on, Walker, what are you doing today?
Oh.
And then this side over here is the small side, 6 and 9. Do you see that?
Yeah.
Are you good now?
Yeah.
Is number 10 just no?
All right, let's look at 10. All right. Now on number 10, it's kind of tricky because you can say that A is shared.
Yeah.
Do you agree? But the problem is it doesn't tell you that BC is parallel to DF.
Yeah.
So because it does not tell you that, we can't assume, all right? And so if they're trying to make it that way, so sometimes on the test, what I tell kids, if they don't say it's parallel, if you draw it in some other way, you can clearly see what? That they're not similar now. All right, they're not similar because the angles are not equal. All right, that's one of the hardest things. When they draw something to the right scale, it looks as if you can say they're similar or not. All right, so the main thing for today was side, side, side similarity, angle, angle similarity, and then what? Side, angle, side similarity. All right, good luck. Finish it up.
Maybe you should just not give us something. Or we just give up with your question.